All right, we just came back from coordinate deck type model video. I've combined both the deck type model with the demonstration of explaining the performance. So we're getting back into the technical. I understand that this video was also technical, but this one we're going back into actual code. All right, we're going to be looking at code now. Back to the same kind of flow that you could expect from the pipeline videos. And this is actually another pipeline where we actually start parsing the replays. So before we started talking about deck type model, I had a video where we were scraping the replay JSON from the replays. Now that we have that JSON, we actually have to parse that JSON to try and figure out what cards were seen for each game, how much games were there, the results of the games, who went first, who were the players. All the information is in the JSON. We got to parse it out. All right. So that's what this is video is going to be about. I have a replay parser. This is actually a pretty I think this is a pretty in-demand thing for those who knows about getting a replay JSON, but yet doesn't actually parse. I've seen a Streamlit Python application from Red Gadget. I'm not sure that is, but there's a Streamlit application from Red Gadget where you give it the replay JSON, and it wouldn't actually tell you what kind of cards a player have seen in a game, or it wouldn't even tell you like how much games are in the match. Like it would just tell you what cards were seen in that it'll just tell you unique cards that were said in that JSON, right? So this is the difference between an application like that versus project like this. In the case that you need a parser to parse that replay JSON so that you can know the details about what's going on in each game. Cool. All right, cool. So let's close that up. Let's open up run replay parser. Alrighty, so we're back to the pipeline stuff. All right, so we have a pipeline here called run replay parser pipeline. Here's how it look like, and let me actually turn this like this. All right, so we have run replay pipeline. So this is the entry point function, of course, if you guys are familiar from the last pipeline videos. So this one is actually a bit different from the other pipelines as well. Recall the very first pipeline with the Excel pipeline. I just had the extract, transform, and load logic here in this entry point. And then with the scrape pipelines, I had to use an async pipeline, right? So I had to use asyncio. I had to use an AO meter to do concurrency management. And I've done that twice to scrape the replays and to scrape the decks from my library, right? So we've seen that with AO meter and tenacity and retry mechanisms and all that. This is the third one. This third pipeline structure is very similar to the AO meter one in the sense that you need some stuff. Tasks are going to be run concurrently, and you need a manager for them. But we're not going to be doing things asynchronously. We're going to be doing things we're going to do multi-processing here. All right. And the difference obviously between multi-processing and doing async stuff is that async is for IO bound tasks when you're doing network requests. For multi-processing, I'm going to be parsing cards from replay JSON. So I'm going to be making GET requests to, the replay JSON from S3, and that's a network thing. But I think the bottleneck is actually going to come from when my model has to predict what deck type the cards from a game was, right? So for that modeling, that's going to be a CPU bound task. And so I've designed this pipeline to use multiprocessing, all right? But the flow is actually very similar to the AO meter one, because you kind of have this manager here that process all the jobs, and it's kind of the same thing. Okay. All right, cool. So let's get this started. So here's the entry point, the run pipeline function in this run replay parser pipeline. So first of all, you have to set up some multi-processing stuff for logging. You got to make sure you do this because whenever you're running, whenever you're doing some multi-processing, and you also want to do logging, you want to make sure that it's writing at the same time to one file correctly without issues. And so you need a queue for this. So this is actually a utility I made. It's in the utils folder. Okay. So that's there, just set up logging for multiprocessing. And then the next step is we're going to get pending jobs. So very similar to the replay scrape pipeline. We want to get our pending jobs here. So we're going to give it our database session, and we're going to call this one function here called get pending jobs. And that's down here. So get pending jobs takes in the database session, and it will look at my jobs table, and it will look for the state when S3 is completed. This means that the replay JSON is available and is in S3. All right. So it'll look for the available S3, replay JSONs, and it would, return to me the IDs of those things. Yes, it'll return the ID, league match ID, and it'll return the S3 key. Okay. So get pending jobs returns a tuple, a list of tuples actually, of the league match ID of these jobs and the S3 key. Because I'm gonna need an S3 key to make the get request to get that JSON and then do stuff to it, right? So this thing returns a list of pending jobs. Okay. So now we have a list of pending jobs. And now we have our multi-processing pool here. So we, configure with some stuff here. And then there's also a settings here as well. I kind of neglected to mention that, but I'll talk about it in a moment, I guess. But in this processes input here, you would define how much CPUs processes that you want to run for this pool. Your initializer, this is the stuff that you would run at first before you do any multi-processing that all processors have access to, right? And this would be defined right here. We'll talk about it in a moment. So this is the initializer, and then we have a log queue, and this is for logging, right? So we're going to give it to this context manager, and it's going to run this process job function that we have defined here as well into that like for loop, but with multi-processing. All right, cool. So let's get to it. So we just talked about get pending jobs already. So now we have a list of jobs that we want to process. And the next thing we have here is worker initializer. So we give in worker initializer to the initializer input of this pool context manager. And what it does is that prior to processing these jobs across, the CPUs or the cores, prior to that, if you want to set up global things, you would do that here so that you're not, initializing things on every process, on every job. So you're not, setting up the S3 client or, things like that every time. So what I put in the initializer is number one, I initialize the logger. So number one, I initialize the logger because all of them is going to use that same logger. And then I've also set up the S3 client. All right, because I don't want to initialize a new S3 client on every job, right? Same thing for the replay parser. This is a class that I've made that actually parses the replay. I don't want to do that multiple times because this parser also loads in the models, right? So I don't want to load in this model for every job, okay? So this is the initializer that runs first, and I made these globally available for all the jobs across the course. Cool. So that's the worker initializer, and then after that we have process jobs. So this is the function that's going to be looped over across all the cores, and this function takes in the jobs that we've gotten with the get pending jobs function here. Recall this is a list of the IDs and S3 keys for each job. So this takes in a tuple from that list. So for each job in that list of jobs, this process jobs would run, and what it would do is, first of all, it would deconstruct the tuple into the league match ID and S3 key. And then there's this database context manager here, where it would extract the replay from S3. So this is the actual logic for processing the jobs, right? It's right here. So for each job, it would extract the replay JSON from AWS S3. So now I have the replay data as like a dictionary, okay? So now I have the replay data, and then I would give in the replay data with the league match ID or the job ID to my parser. Okay, so my parser would now take in this league match data and return me the parsed data from that replay. And once I have the parsed data from that replay, then I want to load that into my database. Okay, and that's what this does. Load tables to database. Great. So that is the process job function. This is going to run for every job across cores and make things go very fast. Okay, here we go. So extract replay from S3. So we see here in our process job function, the first task here is to extract the replay from S3. So what we do is I have an S3 client already. I initialized it in the initializer, but we also have an S3 client in the utilities that has a method to get the object given an S3 key from my AWS S3 account. Okay, so it takes in the S3 key and it gets the object, or it'll give it to me as a string from S3. So now I have a string of that JSON right here in replay string. And then, you want to then load that JSON from a string to a dictionary. Okay, so extract replay from S3 is very straightforward. I'm getting the replay as a string from S3, and I'm transforming that into a dictionary. Great. So this returns the dictionary right here of replay data. So this returns replay data that has a replay JSON. Now I'm going to call this parser right here. Global parser, parse replay. I'm going to give it the replay data and the leak match ID. So let's look at this parser that I made. Okay. So this is from the transformers. So go from our GFL data transformers. We have a replay parser. So this is our replay parser. We've already initialized this once, and it's globally available for all the cores. And we can see here that this is where it loads in the model that we've done in the deck type model video. So we have our label encoder here, we have our vectorizer here, and we have our model here. So everything's already loaded, initialized. It's only done once. It's not done for every job. Great. And here's the public method that is being used to parse the replays. So this method is called parse replays. It takes in the replay data, that replay JSON as a dictionary, and it takes in the ID as well of that job, and is going to return a pandas data frame that contains the parse data frame of that data from the replay. So first, we do some validation. If this replay data does not pass the validation, then there's some kind of error. Just skip it. All right, so let's look at this validation actually. So in this validation, first you want to make sure that the replay data is a dictionary. This would be implied with the JSON loads function, because if that JSON loads function failed, then it wouldn't be a dictionary. So this probably isn't necessary, but it's there. And the next one is whether or not there's a place key in the replay data. Let me think for a moment. Let me close that out. Let me pull this up. Let me learningbook.com/replays. Fuck. Here we go. All right, I want y'all to see. Give me a second. I want you to see what the JSON looks like. All right. So right here, here is the replay JSON. All right, and here's how it looks like as a dictionary or as actual JSON. So you see here that there is a place. Well, here's a preview of it actually. So you see in this dictionary there is this place key. This place key has the turn-by-turn, play-by-play log that I need to parse. Okay, so this thing is not here, then I can't do nothing with it. And if you expand the place key here, you can see each play, right? So play is rock, paper, scissors. It says right here. Play is rock, paper, scissors. Player one choice is paper. It's 10 seconds in. The winner is whatever, et cetera, et cetera. So you can see that each play is here. So rock, paper, scissors. This player picked first. This player shuffled hand, answered main phase one. This person normal summon. This person declared effect. So on and so forth. And then when someone loses a game, they'll say like lose game or admit defeat or quit or whatever, So these are all of the plays. This is what we're going to be parsing. So this place key got to be available in this replay data. It's never been a problem, but just because it's an easy validation setup, I defined it here. Okay, so validate replay data. If it doesn't do that, then it doesn't have what I want. Cool. So the next step is to create the place data frame. So let's look at this. So create place data frame from the replay data's place log. So this method takes in the replay data dictionary. And then for each play in the place key, I want to pull out some data here. So the thing that's actually pretty annoying about each play in this place dictionary is that for the log, so if you look at this, let's look at one of these here. So in this play, view graveyard, let's say, no, two hand. If you look at two hand, this is an example of one play that we're looping through. In this one play, we can see that there's this log key. This log key contains a private log and a public log. All right. And this is also where we're going to extract the card names from as well, by the way. So it has a private log and a public log and username and all that. But sometimes this log is not a dictionary like it is right now. Sometimes it's an array or a list of dictionaries. And in cases like that, I'm actually going to have to confirm whether or not it's a list or a dictionary. And then depending on that, I'm going to append that data into this base dictionary to then turn to a pandas data frame. So unfortunately, I don't have the schema of these data frames to show y'all how this actually looks like. But the TLDR of it is for each play in those plays dictionary, I'm pulling the seconds, the play, the owner, and I'm pulling the logs as well. And the logs, I'm pulling the private log and the public log. Okay. And this is called a plays data frame. For the rest of this parsing, this is what we're going to be using. And with this is how we're going to parse out the number of games in this match and the kind of cards that we're seeing in these games. Great. So now we have our plays data frame. And we're going to do some, now we're going to calculate some columns in this plays data frame. The first one I'm going to add is the card name. I'm going to add a card names column. I'm going to add a deck change column. And I'm going to add a game number column. So let's go through these one by one. So in this card name column, I have this method here called extract card name. So an extract card name is going to look at each row in that pandas data frame that we just made here from the plays data frame. So it has access to seconds, plays, owner, and private log and public log from the logs right here. Okay. So extract card name is going to first of all it's going to make sure that the play is not a dual message. This is an important step here. Because if you look at this, you see this play says dual. Let's look for a dual message here. All right, dual message, right? This is when someone types a message in this chat box here. So dual message, username Druv is bad. So this guy right here, he typed in the chat, standby phase, whatever, right? If you don't make sure that you're not looking at dual messages, what would happen is that in this log, what I've seen is that someone would copy. It's actually common, but someone would like copy and paste a log from here to try to confirm that like they're trying to do a take back, right? So someone accidentally did a play and they're trying to make good faith to the opponent by like putting the card back, and they would like copy and paste the logs from here. And sometimes that log would contain a card name. So you want to make sure that card name from the logs is not being a card they're trying to parse as something that someone has actually seen in the game. All right. Cool. So that's very important. First of all, you want to make sure that the play does not equal the dual message. Just get out of there if it is. And then the next one. So for log in private and public log, I want to look for anything that is within double quotation marks. So I'm looking through private and public logs for messages or cards that are in double quotation marks. And the reason for that is that in these private and public logs, let's look here, to graveyard, right? I'm looking at log, I'm looking at public log. It says sent this card from hand to graveyard. Whenever something is in double quotation marks like this, that usually means it is a card name. All right, so that's where I'm getting the cards from. And you want to look at both private and public logs because depending on the play the person did, like showing hand, shuffling, viewing deck, those kind of things, the card name might have been seen, but it might only be in a private log and not just a public log. All right, so you want to look at both of them. All right, so you're going to look at both logs and you're going to want to check for whichever one matches regex, which basically means that if there's a card name in here, pull it out, return it, and get out of there. All right, so this looks at private and public logs for each play and pulls the card name that someone has seen. All right, in the logs. Cool. All right, great. So that's the card name. So now we have the card names from the logs. Next, we have deck change. So this is actually the complicated one here. So for this one, someone is seeing a card, right? Say, all because a card is in this private or public log. If you want to actually know how much copies of a card someone has seen in a game, you can't just look at the number of times that card was shown in the private or public log. Because say I've drawn Thunder Dragon and I've revealed it in my hand. That would be shown twice in two different plays. One reveal hand, one drawn cards. And they'll say Thunder Dragon twice. If I just did the count of Thunder Dragon in this game, I would get two. And you would think that this person has seen two cards in a game when really I've only seen one card, the Thunder Dragon. Right? So you want to be careful about that. And the way we're going to do that is with this column called deck change. All right. So what deck change is going to do is going to determine whether cards were added or returned to the deck. All right. It makes sure that whatever card that is said in the logs, whether it is something that it is a new card that they've seen, or it is a card that they've had, but they're like moving around, like they move it, they summon the card, they set the card, whatever. They're not adding that as a card that is seen. They're not adding that as a second copy of whatever Thunder Dragon. Okay, and at the same time, you also have to control for whether a card was returned to the deck. So this is actually a pretty tricky one as well. Let's say I've drawn Thunder Dragon. Okay, I've drawn Thunder Dragon, and my opponent trap does shooting me, and they trap does shooting my Thunder Dragon. All right, so now my Thunder Dragon is back in deck. A bit later, I've redrawn the Thunder Dragon. So if you don't control for cards control back to deck, it would look like I've drawn two Thunder Dragons. That I've seen two Thunder Dragons when really I've seen a maximum of one. So what calculate deck change does is just like whether the card was added to your added from deck, and that would be like from drew, or whether the phrase contains from deck, from top of deck. Basically, any action, any play where a card was removed from your deck, that is from deck. That means you've seen a new card. All right. So what from deck could mean is like, from top of your deck to graveyard, you're adding a card from deck to graveyard, you're banishing a deck from graveyard like Nobleman, or from top of deck, from top of deck, you see stuff like that as well. Or you're drawing a card. If a play contains these phrases, a new card is being shown from deck to a player's possession. And then returned to deck. So a card is returned to deck usually just is two top of deck or two bottom of deck. If the play contains those phrases, cards going back to the deck. All right, cool. And then you also have zero in the case that it's the same card, but someone is just like moving it around. Okay. So calculate deck change, that's what it does. Determines whether cards are added or returned to the deck. All right. Cool. So now we have this column called deck change. We're going to be using this to calculate the number of cards a person has seen in the game. Okay. Now the next column here is game number. So we're going to be looking at public log, and if the public log says choose to go, then that means that a new game has started. Okay. So that's the game number, and we're going to do a cumulative sum on it. So if someone's seen, so if a play says choose to go, that's game one. All right, game one, all the plays. If the person, so if down the line a new play says choose to go again, if it says it twice, that means that there's two games in that replay, and then you can just do the cumulative sum where you have one game, second game, third game, so on and so forth until the game ends. So there's different ways that you could define the game number. You could do it this way, where I define it from the beginning, choose to go. You could also define it so that you have a starting point and an ending point. For instance, I'm defining the start of the game number as choose to go. And I'm ending the game number with some kind of thing that suggests that the game has ended. The issue with doing it the other way or adding that way as well is that there's multiple ways that a game could end. A person could admit defeat. Person could quit the game. Person could disconnect. Person could quit, and there might be a reconnect, right? So there's different ways that a person could end the game, and I didn't have all the combinations. You know what I'm saying? So this was the simplest one that was fine with me. All right. So with these new columns, well, what we have now added to our plays is we have the card name, we have the deck change, and we have the game number. Great. All right, so now we're going to pull out some more data from the logs. We're going to pull out the play that, which I'm not sure if this is when the game started or when the game ended, but this is a timestamp from the logs or from the replay JSON. So play that. We're going to pull out player one and player two. This is defined in the logs. So if we look here in the logs, you can see player one and player two. So player one here is Drove is bad. Player two is the white mage. The way Dueling Book defines who's player one and who's player two is by who hosted the game. So Drove probably hosted this game, and that's why he's player one. All right. All right, cool. So we have player one, player two, play that, and now we're going to create this game's data frame. This is the completely parsed data frame that we want to return to our pipeline. All right. So let's look at this method: create games data frame. So create games data frame is going to take in that timestamp that we parsed out from the replay, right? So to play that timestamp, We're going to give it the player 1 name, player 2 name, and we're going to give it the plays data frame that we have with now the card name, the game number, the deck change, the seconds, all that. All right. So with all those inputs, the game's data frame is going to give you a fully parsed table that I can actually show you an example of in our database. All right. So create games data frame incorporating plays and deck type predictions. All right. So we're going to do a loop here. Okay, cool. Yes. So we're going to do a loop here. We're going to do a loop through each game. All right. So we're going to loop through each game in our plays data frame. And what we're going to do is that we're going to extract, oh boy. Yes, because the data that we're trying to parse out from this is game by game, right? For each game, I want to make a prediction on the cards that were seen for that game. And the reason for that is that once we get to the Go Format Analysis notebook, whenever you are defining a deck, you want to do that defining that prediction on the cards that were seen in game one, so that there's no confusions in the post side games where someone might be bringing in like a smoke screen, someone's bringing in cards that might switch the prediction from a deck that was Chaos Turbo in the main deck, but then they set it in like Reinforcements of the Army and Blade Knight, and now the deck might be predicted as Chaos Warrior Turbo when really it's still Chaos Turbo deck, right? That match is a Chaos Turbo game one match main deck. Okay. So what we're going to do here is that for each game, I'm going to pull the cards that we're seeing for each game. I'm going to make predictions on those cards for each game. And that's why we're looping through each games here. But the first thing we had to do actually was to create this card data frame. So if you look at that, this takes in the plays data frame that we made earlier. And what it does is, okay, so what this thing does is that this thing actually creates the card amount column. So let's actually look at an example here. So in database, in games, this is a table that we're ultimately going to be making, okay? So just to show you how this looks like. So we have our league match ID. We have to play that timestamp from the replay JSON. We have player 1. We got player 2. We got a player 1 deck type. This is what our model predicted, right? With the cards seen in this game. And just to rehash again, each row here is a game, right? So in this one, first example here, this was probably a 2-0, right? These are two games of the same match, okay? So you can see in this first game, the player 1 deck type that my model predicted was Chaos Turbo, and the second game was Chaos Turbo. And my model was 97% confident on game 1, 70% confident in game 2. And then for the opponent, Ali, you would see that my model predicted Chaos Warriors as game 1 with very low confidence of 50%, and then Warrior for game 2, 99%. All right. So these are different games. And we can see the cards that my parser has parsed from the replay JSON. So these are the player 1 cards. It gives it to you as a list of dictionaries. You can see as I'm hovering it, the tooltip here says that, it's a list of dictionaries. And you see that, the first one there, it says card name is Black Luster Soldier and the card amount is 1. So I'm including the card amount, which is the ratio of that card that was seen in that game. You expect card amount to be between 1 to 3, right? So that first card there, card name, BLS, card amount 1. The next card is Delinquent Duo, card amount 1. Next one is Spy, card amount 2. And next one is Fate, card amount 1. Mirror Force, Thunder Dragon, card amount 3, right? So that looks appropriate, right? We have the cards seen in that game for player 1, and we have the card amount from 1 to 3 of the cards that they've seen. And likewise for player 2. And then we have the game number. So this is game 1 and game 2 of the same match. Then we have the game winner. This is the guy who won. Nice boy. He won game 1 and game 2. And then I have who went first. So you don't just want to collect who won the rock, paper, scissors. You want to know the person who won rock, paper, scissors, whether they decided to go first or second. Majority of the time, they're going to pick to go first, obviously. But this makes sure that this person went first for that game. Right? Then you got some other stuff here. Don't have to include the replay stuff because there's a relation here with the league match data frame or the league match table that has the replay, your URL, ID, stuff like that. So this is the ultimate. So ultimately, this is the game's table that we want to output from our parser. And cool. So we have that. The first thing we got to do is actually parse or not parse. The first thing we have to do is calculate the card amount column to know how much cards was seen in a game for a player. So I give this method the plays data frame, right? And if we look back up here, okay, great, yeah. So we give this thing the plays data frame, and we're going to do a cumulative sum of that deck change column. So remember that deck change column. It'll give a value of 1 if a card was added from deck. If a card, if a card was new, right? If a card was added, it's 1. If a card was put back to deck, it's -1. Yes, if the card was put back to deck, it's -1. And if a card is just being moved around, but it's being mentioned multiple times in the logs, but it's not added or removed, this is 0. So I'm calculating the cumulative sum of the deck change, right? So let's say there's an example that the example I had before, Thunder Dragon and Dust Shoot. I've drawn Dust Shoot, or I've drawn Thunder Dragon, and then my opponent Dust Shoot away the Thunder Dragon, right? So in my data frame, in my plays data frame, it would be a 1 for me drawing the card, right? And then there might be a 0 because my opponent selected Thunder Dragon, and now it's in the logs, Thunder Dragon been selected by the opponent, right? So it might be like 1, and then it's 0, and then me, I'm going to put that Thunder Dragon back in my deck. So now it is a -1. So it's a 1, 0, -1. So if I did a cumulative sum in my data frame, it'll be like 1, 1, 0, right? Because it's 1 plus 0 is 1, cumulative sum, 1 minus 1, now 0, right? So now I have this cumulative sum of the deck change. It's 1, 1, 0 in my example. Then the next thing you do is actually get the, you do a group by with the game number, username, and card name, and you want to pull the maximum value from cumulative deck change, right? So I have this cumulative sum of 1, 1, 0. You don't want to pull the last value because you have seen Thunder Dragon. It's just at 0 now because it's put back to deck. What you want is the maximum value from this column. In this case, it'll be 1. In this case, the maximum amount of times that you've seen this card, the maximum, number, card amount is 1. I've seen 1 Thunder Dragon in this game. Okay. That is how I pulled the card amount from the replay JSON. This is the method I do. First of all, I calculate the deck change, whether a card was added or put back to deck. And then I do a cumulative sum of that deck change to find out, I do the cumulative sum of that deck change, and then I pull the maximum number from that column so that I can find out at what point, how much copies have I seen in that game, okay? Okay, so this create cards data frame is going to give you a cards data frame with now the card name and the card amount, okay? Great. Alrighty, so let's go back here. Okay, so now we have our card data frame. So for each game, for each player, I'm tracking the card that they've seen and the ratio of it that they have seen. Now I'm going through each game number and I'm pulling out the rest of the data, right? So I'm from the card data frame for each game, I'm pulling out the game number equals whatever game. The username is player 1, and now I have players 1 and players 2 cards for this game. And then in here I make the predictions, right? So I use my model in this private method here, predict deck type, where I give it the cards that a player have seen for a game, and I'm doing the steps here to do the modeling, right? So I'm doing so if you recall from the deck type model notebook that I've had, you have to concatenate the card names into the separator with the pipe separator. Then you have to vectorize the data, right? With the vectorizer that is already configured to do the separation by the pipe character. Then I have the prediction, then I have the predicted type, and then I have the prediction probability. This prediction deck type is going to give me a tuple of the string being the prediction that my model has made, and the float being the confidence that my model was in that prediction. Okay, so this is the method that I use using the model that we built already before to predict the deck type of the cards seen in a game for a player. All right, cool. So let's see here now. All right, cool. So now I have player 1's cards. I have players 2 cards, and I have their card name and card amount. And then I have their predictions given the cards, right? So I give him player 1's card, and now I have player 1 deck type predictions, a tuple, again, of the deck type and the confidence. And then what happens here is that for each game, I'm going to append this dictionary of some base data here from the base. So I have player 1, player 2. So that's going to be here in this dictionary, along with the game number, game winner, went first, player 1 cards, player 2 cards, the deck type confidence, etc. Right? So now, for each game, I have a dictionary that is all in this list that I'm going to turn into a pandas data frame. So now I have a pandas data frame of all of these columns. Great. That is the game's data frame. This is essentially the parsed data frame that I'm going to return. Okay, so if we go back up here to the public method that we've called. So now I have the game's data frame, and I logged that things went well, and I've returned the game's data frame. Okay, the end. That is the parser. All right. Basically, if you were to use this parser, this file alone, and whether or not you want to have the deck type or not, as long as you give the replay data as a dictionary to this parse replay, this thing will be parsed, right? So that's the power of modulating, this parser into this class, where someone could just take this file and say they want to remove the modeling steps because say they don't have a model, or you can use my model because the repository is public and the model is there as well to download. You could just give this thing a replay dictionary of the JSON, and it could give you the parse data for each game of that replay. The only thing I will mention is that this parser is supposed to parse games from the Go Format War League. Okay, in Go Format War League, there is no match rematches. Okay, there's no rematches in one replay. So that's the one caveat here. I did not deal with the case of if there is a rematch. I'm actually not sure what would happen because I don't know how the logs look like on a rematch. If there was a rematch, then you would have one replay with multiple matches. So that's one caveat to keep in mind about this. This would not handle if there was a rematch in a replay. Okay. All right, cool. So now that I parsed the replay, I have this game's data frame. And now I could just take this data frame and load it into my database, right? So load tables to database. It's going to take in the database session, the ID of the job, and the game's data frame. And it's going to call this function right here. Okay, so for each row, it's just going to populate all these columns here in this game model. And it's going to commit that to the database. Cool. That's the end. All right. So just to recap here, if we go back to the run pipeline function, we did some setup for the multiprocessing. And then after that, I got the database session. I got the pending jobs, right? So I got a list of pending jobs, and then with this multiprocessing pool, I've gone through each job and I've run this process job function. And this process job function, it extracted a replay from S3, it parsed that dictionary into a game's data frame, and then it loaded that data frame to the database. All right. All right, cool. And just to show the end result again, here's the games database, and here's the result, right? So we've seen this already, but it's the result. Alrighty, cool. So nice. So I'll see y'all in this next video where we're going to talk about, finally. So now we're going to get into the actual analysis. Okay, good. So the next video is the last video, and that'll be the end of the series. All right, I'll see y'all there.